Yep, and now people just, instead of buying one for themselves, they try to buy like two or three and sell them. So it's tough to get one.
Yeah.
But I will move on. All right, so
Sorry.
let's plot this point. Let's plot point A. It's 2, 2. How do I get there? How do I move first if I want to plot point A? X, I go right 2, then I do what? Up 2. So I get point A. We're plotting points, and we just plotted point A. Now, you're about to help me plot point B. -3, 4. How do I move first? Is X first or Y first? X is left or right. Since it's negative, I go 1, 2, 3, and then what? 1, 2, 3, 4. All right? Everybody okay doing this?
Yes.
Oh, we're gonna go back to that. We're gonna connect some dots before we do that. All right? Everybody okay with plotting these points?
Literally, though.
All right, so we're gonna do polar points, which involve angles and the radius, which is the distance that you get to this point. So you can convert these points into polar points. So for instance, if I was going to graph this as a polar coordinate or a polar point, what I would do is I would need to know how much of an angle I rotate by, which this can be maybe like 45, and then I need to know how far out to count to go to get to this point. But it works the same way. So this may be like 45 degrees, and then I may have a radius of like 3. And it takes me to this exact same point. It's just another way of getting to this point. Same thing for point B. Maybe for point B, I rotate more than 90 by this way, and then I go out maybe 4. Yeah, so this could be like 135 with an R, which is like the length of my ray, of maybe 4. So you would get a polar point of something like this, right? It's another way to plot these points in what originally we know as a polar coordinate. So you see that weird looking circular polar coordinate? The only thing that's being added is you get these rings just so it's easier to count how far out you go. So like for instance, if I had to go out 3 to get to this point here, I would just go 1, 2, 3. That's why the rings are there. So if I had a point that was maybe here, I would see how much I rotate by. That would be my angle. And then if this was 3, I would go 1, 2, 3. Point F is right here. All right? So these polar coordinates are similar to these points. It's just a different way of getting to it. All right? And it's pretty straightforward. Okay, so it's a new coordinate system for most of us. We call it the polar coordinate system. The system is based on a point called the pole, which is like where you end. We would call this the pole. And it has a ray, which is like the length here, which we call the polar axis. All right, so together they get you to this point. So we got 2 ways of getting to this specific point right here. One way is you go right by X, you go up Y, and boom, I'm right here. Another way is you rotate by this amount, and then you go out by this amount to get to this point. So a coordinate system, rectangular coordinates, when you hear that word, this is a coordinate. So X and Y, that's a coordinate. When you see like a polar point or a polar coordinate, that's what you have right here. So you have R, which is your radius. If you think about the triangle, that's just how far out, how long your ray is. And then theta is just how much of an angle you rotate by. And these are pretty straightforward. Right, questions yet? So let's just graph a bunch of these points. we got steps over here to graph. This is what we're about to do. We'll look at them in a second after we do it a few times. I think it'll just be easier to show you than to do all that reading, and you probably not have a clue what I'm talking about. But let's graph point A. So the way you graph these is you first rotate by the angle measure that you see, and then you go out based on the R value that you see next. So you actually do these kind of backwards. So my first number is 120. Which quadrant is 120 degrees in? Second quadrant. Is it the taller one or the lower one or? This one right here?
Yeah.
Okay, so if I do one of these on paper, what I like to do is I always start on the x-axis here, and I'll say I'll rotate to this angle. And on my paper, I'll do a little mark saying this is my angle. And then if I want to go out 3, I'll go out 1, 2, 3. And that's where point A is. I won't do this little mark here because I'm about to do a bunch of points in marker. But that's how I would do it normally. If I was doing 210, I would go, oh, this is 210. Then I go out 1, 2, 3, 4. Boom. That's my point. Okay, so that's how I do it on paper. Yes, Grace?
Will the rings always be provided for us?
Yeah, when you graph polar points, yeah, the rings will always be there. If they aren't, just tell me, hey, Mr. Shields, this is where 4 is, and I'll believe you. All right, I'll believe you. Don't stress out about it. All right, so we go 120, and then we go out 1, 2, 3. Just like that, that's point A. Questions?
30 is just the reflection.
Let's come back to that one, because it's one little thing to add when we start doing negative R. Just one little small thing. Let's jump and go to D. Negative 45, which quadrant is that in? Fourth. So instead of going positive 45, I go in the opposite direction, and it's negative 45. So this would be my angle. How far out do I go?
2.
So 1, 2. It's point D. Let's do F. Is that the same angle? Negative pi over 4. That's a 45, negatively. So I go down to pi over 4, which is this one. And then how far out do I go? 1, 2, 3. F. All right, and let's do G. 5 pi over 6, where is that at?
150 degrees, that's in the second quadrant.
150. And I know it's tough to see because I had to really, but it actually says 5 pi over 6 if you have good eyes, like Mr. Shields. All right, 5 pi over 6 is here, then I go out 2. And the printer didn't help either. So this is where point G is. Okay, we catching this?
Yeah.
Not so bad, huh? Yeah. The one little catch is, what we've been doing is, whenever your R is greater than 0, what kind of numbers are greater than 0? Positive. Whenever your R has been positive, you just go out based on where your angle is. So if you saw positive 2, you go that direction too. Now when your R is less than 0, what kind of numbers are less than 0? If your R is negative, you go in the opposite direction of your angle. That's as tricky as this will get. You go in the opposite direction. So if we go back and try to do B, originally I would go 30 degrees, which is right here, right? But instead of me going out 4 this way, since it's negative, I go opposite 4. So it'd be 1, 2, 3, 4, and this is actually where point B is.
I got a good guess.
That's the one little thing that makes this tricky. The negatives, if the R is negative, you go in the opposite direction. So like C, take a second. No, nobody say nothing. Let's give everybody a second to think. Where would this, yeah, C. And you just ask yourself this question. Where would C be? Which quadrant would C be in? First you go negative 120. Then you go in the opposite direction.
Wait, no, is it?
You, say all of them. Two. Just go ahead and say all of them.
Is it first?
It is the first quadrant. All right, so first I'll go negative 120. I start here. Since it's negative, I go clockwise. This is 90. Then I go 30 more. Negative 120 is right here. Since it's negative 1, I go in the opposite direction. And the point is right here in the first quadrant. Did that make sense? When Zach gets back with the pass.
I was right with the 30. Since I figured where the negative 120 was.
All right?
Didn't-
Take a second and do E. Take a second and see if you can do E. Don't say anything just yet.
Mr. Schultz, it seems so weird though, because it's like you're going positive whenever it's a negative. Like, because you went up instead of back.
Not quite, because if I would have did positive 120 and I did 1, it would be right here. So I kind of see what you're saying, but not quite.
I'm probably just looking at it wrong, man.
Maybe. See if you can do E.
I think it's on 2 pi over something. I get confused.
Why?
Like, I don't know. I'm scared of them. Because it's like 2 pi over 6.
Okay. The top is how much more or less than the bottom. 2 is what compared to 3?
1 less.
That happens in this second quadrant. Remember when we said 1 less, 1 more? Remember all that?
I got to meet the original.
I thought that was the half angles.
No. When you say like, this is just pi over something. This one is just, the top is 1 less than the bottom. This one, the top is 1 more than the bottom. Like this.
Did you get
So all of these, 2 over 3. Remember we did all that?
Yeah.
So that, so then if I just remember that, that's here. And then the 3s are the 60s.
Oh, so it's literally just, okay.
Just there.
Alright.
Because it's not negative.
Alright, I was trying to like figure something out, but yeah.
Yeah, it's just muscle memory. All right, which quadrant is E in? 4th, right?
It is 4?
So where is 2 pi over 3?
It's in the.
Second?
It's the 120 degrees.
It's 120. So I will remember this like, oh, how do I get to this angle? Well, the top is 1 less than the bottom. That happens in the second quadrant. And then the 3s are always the 60s. So over 3, it's got to be the 60 in the second quadrant, which is this one. So logic would tell me to go here and then go out. But since it's a negative 4, I go opposite this way. 1, 2, 3, 4. This is where E is. Do we need another point?
This is really easy.
No, it's not.
I think so. It's safe to assume that. We need to do another one?
I say that, and then we get homework, and then I'm like,
One more maybe?
G.
One more, all right.
You're G, right?
What's your favorite letter? G? We already got a G.
Yeah.
H?
Oh, my bad. I was blind.
J? I like J. Man, J's a great letter. Especially if your name is Josh. Man. Oh, my name is Josh. Maybe that's why I like, maybe. I didn't think about that. Yeah, my middle name, that's what I go by. All right, so let me see. Let me give you a good one.
Give us an easy one.
All right,
Oh, that's easy.
let's graph J. It's 225 on the unit circle.
Wait, is
I
it
hope
not?
it is. I think it is. I think it's the 45. I think it is. Yeah, 180 plus 45. Yeah. Not on mine. But if you do your own. Not on mine though.
First, found it.
I give you a blank one.
And it's -2, right? Yeah. 1, 2. Yeah, it's right above C. Like, it's like the line next to C. Yeah, this is easy.
225. It's the middle one.
Bless you.
Since it's negative, I go in the opposite direction. 1, 2. Bada bing, bada boom.
Wait, is it right above C? I thought it was.
Oh,
Yeah, there.
my bad.
You're confusing them all, coach.
My bad.
This to her when she comes in. Thank you. Sorry to interrupt.
Hey guys, that's my bad.
It was just a distraction.
Yeah, it was a lot going on.
Perfect. Now we gotta draw that line though to make it look right.
Ah, here we go.
Oh, it's not straight.
You want me to pull out your box project? I saw your circle. Nah, let's get your box project. It's got
I'm just kidding.
Let's talk about some straight lines. What is it?
No, that's while driving and
You
riding.
do it with your left hand, like. I mean, what is this, like? Like how to do this?
No, that's driving while riding.
So relax before you talk about my life.
Yes.
Oh, you got burned.
Like if you squint your eyes and look at this very briefly, it looks perfect.
Wait, I forgot to bring one.
Oh, man.
Monday.
No,
It's called driving and riding, Mr. Shields. It's also done in 5 minutes.
It's called talking and writing and
Driving.
managing and helping people while riding. I don't feel bad about you driving and riding. Maybe you shouldn't drive and ride.
I forgot about turning that in. That's why
All right.
I kept my mouth shut on that one.
Alright, so. Alright, any questions on plotting these points? So, we'll finish with looking at just converting in one direction, and then we'll stop. Next time we start doing stuff, we'll go in the back and do this. So, let's just get a little taste of how we convert these, alright? So, converting is pretty straightforward. It's so straightforward that I'm not going to do this one because it's so easy, it'll probably confuse you. We're going to go to number 2 first. And I'm not even joking. All right, so we got some steps over here. I'm going to do it, and then we can try to make sense of the steps. So
Wait a second, which number 2? Oh,
this number 2.
Never mind.
All right, so this is just an XY coordinate. We're going to plot this. I'll go right 2, and then what will I do? Down 2, which puts me in quadrant 4. So I'm going to just make a little modified something, and I'm going to do an angle in quadrant 4. All right, I went right 2, and then I went down -2 to get to this point. All right, so step 1 is I plot the point. Our goal is to figure out how to convert this so that it's r theta. R is the hypotenuse, right? How do I find the hypotenuse of this triangle? Pythagorean theorem, right?
Just very, very precise enunciation there. It took me.
This is what we're doing today. I mean, he's going to correct me if it's like, there's any kind of accent, okay? So, you could use, how about I just say a squared plus b squared equals c squared, all right? Or we can use this form of it. It means the exact same thing. Okay, so let's find this missing side. I'll do, I shouldn't have wrote it, but here we go. A squared plus b squared equals
C squared.
c squared. I know a and I know b.
2 squared plus 2 squared.
Yep.
16.4. Yeah.
Not 16, 8, right?
Oh, yeah.
4 plus 4.
And 2.
And so I'm going to switch it up just so we got it. I'll get the square root of 8,
2 root 2. Yeah.
which is 2 root 2.
Because 2 times 4 and then becomes 2 times 2 times 2 and then you get rid of 2.
Yep, 2 of the 2's go out, 1 stays in. All right. Also, this is a 45, 45, 90 triangle, so you multiply the x by root 2. You guys don't remember that, but We found out the missing side is 2 root 2. Everybody okay with how we got there? In a very brief manner. Okay, that's my R, just like that. That's my R, so I'm halfway done. I just need to figure out what angle this is at. Which quadrant am I in? So I've only got a few angles to choose from. Now, what do you notice about the coordinates? 2, 2 to 45. In which quadrant? What angle is that?
270.
No,
Close.
it's 315.
315. That's my angle. And just like that, I've converted it. So my angle is 315. And just like that, I've converted it from rectangular to polar coordinates.
So we really need to master that unit circle, huh?
If you master it, it makes your life so much easier.
That's true. It goes for some of the differences.
It makes it easy.
That's why I'm
All right, so let's say it wasn't that logical, and we'll do some that don't have the same coordinates, so you'll have to decide, is it the 30 or is it the 60? What you'll do is just pick a trig function and write a ratio based on what you see. So for instance, let's see what happens when we do cosine of this situation right here. Cosine is which two sides? Ka? What is the adjacent side? What's the hypotenuse? The 2's cancel. I get 1 over root 2. When I rationalize it, what do I get? Root 2 over 2. So my question would be, at what angle does cosine come out to equal root 2 over 2? And your answer would be, oh, the 45 in the fourth quadrant, which is 315. Does that make sense? If you did sine, you would get the same thing, but it would be negative. You'd say, oh, that's the 45 in the fourth quadrant, so my answer is 315.
Your answer can be both.
You can do either one. In fact, if you do it like help me solve this, or you look in the book, or you watch something else, they'll do tangent. I like to choose sine or cosine because you kind of remember it. Tangent, you might not remember. But in this case, if you did tangent, it would just be 2 divided by 2, which is 1. And what angle is tangent 1? 45. So then you say, oh, that's the 45 in the fourth quadrant. Does that make sense? All right, let's go and do this one. So first step, what we got over here, we'll look at these now. You plot it. So let's plot it. Do I go left or right?
You don't like that.
I'm right on this line. Man, that was pretty easy. Okay. What angle is this? 90. 90.
Oh yeah, that's exactly right. So it's just R90?
What's R? How far out did you go? I went 1, 2, 3. Told you that was almost too easy to do first. Because then you'd be like, ah. All right, and we'll pick up here next class. Minimum, if you know your unit circle.
Oh.
If you kind of understand
It
it.
gets me.
You can like, oh yeah, I remember that. All
I
right.
don't know my unit circle that well. I need to like